Hello, and thank you for attending today's webinar. My name is Brad Cook. I'm an applications engineer at Makino in Auburn Hills, Michigan. In today's webinar, we will be discussing the highlights of the die mold process training class. This webinar is designed to give you an inside look to what is taught during this course. There will be a question and answer segment following this presentation. To submit a question, simply type in the box on the left-hand side of the screen and click Submit. Let's start by looking at some of the more common questions asked by individuals before they attend this course. Who should attend? When should I and/or my employees plan to attend? What benefits will my company see after attending? What is the structure of this course? Answering the question, who should attend? CNC programmers will gain programming techniques, advanced cutting condition calculations, control and machine capabilities, along with safe machine operations. Machine operators will learn control and machine operations, laser and probe operations, and basic machine care. Managers will get a better understanding of Makino practices and how to implement these practices, along with learning what is possible with the machine and control functions. When should we plan to attend? It is best to attend before your machine has been delivered and/or installed. This class will help you prepare and purchase the proper tool and tool holder selection for your new machine. Attending before your machine is installed will better prepare employees for machine operations once your machine is installed, which will benefit your company with no machine downtime due to not knowing and understanding the equipment. Applications is continuously developing and implementing new strategies, so there is even a benefit for students that have previously taken this course. You could add new technology to your existing process. One example would be adding or improving lights-out machining techniques. This class is held every 6 to 8 weeks. It is a 4.5-day course, starting at 8:30 to 4:30 Monday through Thursday, and 8:30 to 12 on Friday. Lunches are supplied Monday through Thursday. All needed material, like pens, paper, calculators, etc., are also supplied for your use. What benefits will my company see after attending? The best answer for this would be high-performance machining. Did I hear you ask, what is high-performance machining? High-performance machining is a combination of several key elements, like your machine having a high-performance spindle, high-performance control, the machine design being rigid and thermally stable, and applying all the techniques taught in this course, you will have HPM, or high-performance machining. With high-performance machining, we can gain predictable surface finishes, safe machining practices, reduce cycle times, increase tool life, hard milling capabilities, practical tool selection, and lights-out machining. What is the structure of this course? The DMPT, or Die Mold Process Training class, has been developed to help guide the novice to the advanced machinist. You will gain the knowledge to transform your company from using traditional machining methods to a high-performance machining facility. The structure of the class starts with the history of Makino, going into machine construction, machine controller, tool holders, tooling selection, part setup, cutting conditions, process, CAD/CAM, ATLM, automatic tool length measurement system, and part probing. The history of Makino is the first section that is covered in this course. We do not spend a lot of time on the history, but we do discuss a few key points that link Makino directly to the die mold industry for a better understanding of the company's die mold focus. We discover who founded Makino and where the location of the company first started. We also look at when Makino created its first NC machine and discuss the different die mold technology advancements that have been created by Makino since the company was founded. We discuss how these advancements have made it possible for us to have the high-level machining centers that we have today. We then move on to machine construction. We discuss the key features that are on each of the different die mold machining centers, highlighting its advantages and explaining how it will affect part accuracy, surface finish, machining stability, and or cycle time. We also explain how to take advantage of these features and utilize them on a daily basis. One example of a key technology would be the core-cooled under-race lubricated spindle that is pictured here. This is a patented design which allows the spindle to stay extremely stable for long-running cutting cycles. In class, we show how to maximize the efficiency of this spindle for the best possible machining results. Precision assembly. Hand scraping of turkite-lined guideway surfaces makes for highly precise alignment, exacting surface contact, lubrication pockets, meticulously matched to mating hardened and ground guideway surfaces, accurate over entire travel, tight control over alignment, both static and dynamic, minimize lost motion and backlash in the guideway system, extremely accurate, exceptionally stiff and rigid, and makes for an outstanding cutting platform. The machine control is the next topic that we covered during class. This is a Professional 5 touchscreen control that is FANUC based. We cover navigation and use of the Pro 5 and FANUC screens of the control. Machine operations are demonstrated with hands-on exercises that will help you get comfortable navigating the control, loading and running programs, setting work and tool offsets. We also set up live demonstrations of the machine's functions for tool life monitoring and spindle load monitoring. Control customization and shortcut functions are also taught. Networking the machine is also demonstrated with hands-on group activity. All customers are allowed and encouraged to navigate the machine control to help them better familiarize themselves with the control with the help of an applications engineer readily available to answer any questions that may arise. Supergeometric Intelligence, or SGI.4. Designed and developed by Makino for high-speed machining of complex parts that require excellent surface finishes while holding accurate dimensions at reduced cycle times. Change in vector direction will affect the acceleration, deceleration, or change in average feed rate through the part. All tolerances will affect the change in vector direction. Tighter tolerances could make the machine run faster by adding more points to the toolpath, so the vector change are much smaller than a looser tolerance. SGI is a modal M code. It's programmed on a block by themselves. The M codes that we can use are M250, high accuracy mode, which provides a good balance of machining time, surface finish, and dimensional accuracy. M250 is the default mode on the machine. M251, high performance mode, is used for roughing and semi-finishing operations and results in approximately 30% reduction of machining time over standard mode. M252, ultra high accuracy mode, is best where dimensional accuracies and surface finishes are critical. Fine mode adds approximately 30% to the machining time over standard mode. Bench time is significantly reduced, so this time is well spent. M254, ultra fine mode. This is an optional M code. Used mostly for 5-axis applications, is best where dimensional accuracies and surface finishes are critical. Ultra fine mode adds additional machining time over fine mode. This is a key technology that we spend some time explaining to the class so everyone gets a good understanding on how to utilize this function. Tool holders. Choosing the proper tool holder is key for high-performance machining. We will look at most of the common tool holders used in industry today, which are side lock holders, collet holders, hydraulic tool holders, shrink fit, mill chucks. We will then look at the advantages and disadvantages of each tool holder. This will help us make a decision on our tool holder selection. Tooling is the most costly portion of the machining process. Benefits for proper tool holder selection and application will be tool life will be increased, effective tool life is more predictable, tooling costs can be reduced, balance will be acceptable, and runout will also be acceptable. Shrink fit heat units, induction type compared to air type. We will look at the advantages and disadvantages of both systems, operation and care. Induction type is faster than air type. Induction type is more expensive. Misuse of induction heat will render the holder unusable. Interchangeable shrink fit adapters, MST, are more cost effective than single piece shrink fit holders. Single piece holders have less runout over a two-piece style. Most shrink fit holders are balanced to Makino standards, yet some allow for even greater balancing. Tool holder balancing. What are the advantages and disadvantages? The ability to run at maximum spindle speed and higher feed rates while maintaining extended tool life, exceptional surface quality, extended spindle life. Balancing is mandatory for high-performance machining. What are my balancing options? Buy balanced holders and symmetrical tools rated at higher than max RPM of the machine. Use a tool balancing service. Buy a balancer. What can affect the balance on my balanced tool holders? Retention knobs, collet nuts, collet accuracy, tool body, tool holder condition, and paint pen marks. Cutting tools. Tools for high-performance machining have a number of variables involved in application usages. Different steel grades and hardnesses will determine your tooling choices for cutting tool selection, geometry, coatings, carbide quality, manufacturer standards, applications and uses. In the class, we will discuss how the length to diameter ratios are determined by the cutting tool diameter and/or cutting tool manufacturers. What is spindle allowable cutting forces? Makino uses spindle allowable cutting force charts to determine safe cutting conditions. Every Makino spindle has a different range and should be understood to minimize the risk of damage due to excessive loading conditions. In the class, we will learn how to calculate these spindle allowable cutting forces. Machine setup. Climate considerations. What is the shop temperature from AM to PM and from day to day? Probe and laser calibration. How often do we recalibrate our spindle probe and ATLM? Stacking tolerance. What is stacking tolerance? Stacking tolerance is a combination of your cutter's runout tolerance, cutting edge grind tolerance, proper extension causing deflection, holder's runout tolerance, holder's cleanliness, current condition of holder, table accuracy, table cleanliness, flatness. Are you stoning out nicks and burrs from the table in part holding, or fixturing? What options do we have for part holding? We can use a vise, a magnet, toe clamps, chucks, reference system, tooling plates, a ROA, System 3R, fixtures, or any kind of custom-made fixture. Machine readiness. Check weigh oil levels, provide machine requires. Validate spindle cooling system is filled sufficiently. Inspect all coolant levels to satisfy cutting condition. Provide coolant or air oil mist is used. Verify the grease system is working properly and is full. Cutting conditions. During the class, we will look at the effects of using coolant, liquid, or air during cutting. We'll learn how to calculate surface feet per minute, chip load, speeds and feeds, depth of cut, effective diameter, complete charting of cutters. We will also learn about flush fine machining, which is a Makino patented machining process for material 40 to 60 HRC, patented in 1993. Cutting conditions. During the class, we will learn how to calculate all cutting conditions. We will be able to calculate and program to a predictable surface finish that is based on part geometry, job requirements, and tool shape. We will also gain predictable tool life and faster cycle times from these calculations. Process. We will learn how to create machining processes that will allow us to gain the highest metal removal rate based on part geometry, minimize cutting tools, also based on part geometry, eliminate tool breakage due to the fact that we will not be banging into corners and cutting excessive stock. We will be able to achieve the desired part accuracy. We will also produce faster cycle times and maximize machine capabilities. CAD/CAM. In the class, we will discuss and demonstrate what we'd like to see in a CAM system. We'd like to see a CAM system running in a 64-bit operating system, the ability to produce accurate and reliable toolpath, being able to modify leads and links to suit our needs. We'd like to see a CAM system with a great corner remachine capability, automatic gouge checking, tool collision verification, tool holder collision verification, the ability to have accurate and smooth point placement. This will give us the best results on the Makino machine. A CAM system that should be easy to use. ATLM, Automatic Tool Length Measurement. During the class, we will spend time on the machine training on how to use the ATLM in all of the measurement cycles. We will discuss the benefits of having an ATLM. We will show you how to utilize the ATLM in an unattended operation to check tool length and tool breakage before and after the program to help eliminate operator error. Part probe. During the class, we will spend time on the machine training on how to use the part probe in the measurement cycles. Some of the benefits of having a part probe will be the ease of part pickup, eliminating operator error, using the part probe to measure finished part details. In this webinar, we have taken a look at who should attend, when we should plan on attending, what are the benefits that your company will see after attending. We also had an opportunity to see some of the highlights from the die mold process training course. I hope that this webinar has answered your questions and has encouraged you into attending the die mold process training class. We will be looking forward to seeing you in the near future. Thank you for attending the die mold process training class highlights webinar. This webinar will be viewable in Makino's archive at www.makino.com in the webinars library. We'll now begin our question and answer session. If you have any questions, please enter them into the box at the left and click Submit. We will begin answering them shortly. If you're viewing this As an archive, please submit your question and we'll respond by email as soon as possible. Thank you.